Welcome to this explainer. Today, we're going to completely demystify Python and Pygame. And we're doing it by building an entire cosmic universe right inside a single script. But here's the secret. We aren't going to rely on dry theory or, endless reading. Instead, we're unlocking the power of play. We're diving into a really fascinating concept called play-first programming.
Okay, let's dive right in with a simple, maybe even slightly rebellious question. Even if you've been coding for years, traditional learning tells us we absolutely have to memorize syntax before we can build anything. But can you actually learn complex coding theory without a single flashcard? Just by tinkering, twisting knobs, and frankly, breaking the rules? The play-first approach literally flips the classroom on its head. It suggests that by deliberately messing with a working system, you actually absorb the concept so much faster and a lot deeper.
So we start with our end goal. Our vision is to create this calm, hypnotic, full-screen midnight black window. Just picture hundreds of softly glowing neon stars, tinted cyan, magenta, or white, drifting slowly across the void. Each little point of light has its own unique speed and color. And when a star drifts off one edge of your screen, it seamlessly pops back up on the opposite side. It's calm, it's hypnotic, and most importantly, it's going to be completely under your control. But here's the cool twist on how we actually get there. We are not going to type out 100 lines of boring boilerplate code from scratch. No way. Instead, we use this exact AI prompt as sort of a magic spell. We tell the AI assistant exactly what we want. A Pygame window, a midnight black background with specific RGB values, 50 star objects with randomized attributes, and a main game loop. By explicitly asking for clean, readable code with short comments marking our variables, we instantly let the AI do all the heavy lifting to generate our baseline project.
All right. Let's assemble our sandbox. It's a super rapid four-step process. First, copy that generated code right from your AI chat. Then open idle, which, if you didn't know, is just Python's default editor. Paste the code in, save it straight to your desktop as stars.py, and just hit F5. Instantly, boom, a Pygame window pops open. You aren't just looking at a wall of text anymore, you're running a real native desktop application.
So, the crucial point here is that our beautiful black box is now fully built. And sure, you could just sit back and admire the default version, but honestly, that's not why we're here. The sandbox is ready. Now it's time to deliberately open it up, twist the dials, and organically discover exactly how the mechanics work by breaking things. Let's push the system a bit. Ask yourself, what actually happens to our 50 calm, drifting stars when we deliberately unleash a totally chaotic star storm? We really want to push the boundaries of the script and see how it reacts to extreme conditions. To do this, we just look near the top of our script for the variable that controls the count. And because of our clever prompt earlier, it's clearly labeled. We find star count equals 50, or maybe a loop that says for I in range 50. We're going to drastically change that number from a peaceful 50 to a massive, chaotic 3000. Save it, hit F5, and just watch the screen completely explode with light. Now, this brilliantly illustrates a massive difference in technologies. If you tried rendering 3,000 moving objects in a standard web browser document object model, your CPU would probably start begging for mercy. But here, Pygame is talking directly to your graphics hardware. It renders those 3,000 stars smoothly and effortlessly because your GPU is built for exactly this kind of job. I mean, you just learned about hardware acceleration simply by changing a single number. How cool is that? Okay, next experiment. What happens when we completely shatter the speed limit of our simulation? Right now, the stars are just sort of drifting. But what if we want to fly? We dig into the script to find where the speed is assigned. Originally, it's a slow decimal, something like 0.5 to 2.0. By tweaking these velocity values to range anywhere between 10 and 40, we hit F5 again. Instantly, your calm star field becomes a warp drive. The stars are moving so fast they actually leave visual impressions across your screen. It literally feels exactly like looking out the window of a spaceship making the jump to light speed. All right, for our final experiment, let's twist the color settings. How can we change our cosmic palette from the default cyan, magenta, and white that the AI originally generated for us? Well, by finding the list of colors at the top of the file, we can easily inject brand new combinations. By typing in the numbers 255, 165, and 0 inside parentheses, suddenly we have neon orange stars. Swap it out to 57, 255, 20, and you've got glowing neon green. You could even delete all the colors except one to create this really moody monochrome star field. You're instantly altering the entire vibe of your universe with literally just a few keystrokes. So, what's the real takeaway here? This is the grand reveal, the hidden coding lessons you've just unlocked. By having chaotic fun, by unleashing star storms and warp drives, you just stealthily absorbed real foundational computer science concepts. And you did it all without sitting through a single boring theory lecture. For example, if you've ever built a website, you're probably pretty familiar with HTML hex codes, like #00FFF for cyan. But as you just saw by tweaking the code, Python's Pygame uses RGB tuples. It's the exact same colors, just a totally different notation. 3 numbers, representing red, green, and blue, on a scale from 0 to 255, completely control your palette. And under the hood, this highlights how motion actually works. In a web browser, animations are often handled by a function called request animation. But here in Python, you just interacted with Pygame's explicit while true game loop. This is a loop that runs continuously, constantly clearing your screen and redrawing every single star, typically 60 times every single second. That right there is the absolute heartbeat of a desktop application. Finally, let's look at how we generated that awesome warp speed. It really comes down to the difference between two Python random functions. Random.random gives you rigid whole numbers, but we used random.uniform. Why? Because uniform gives you decimals. You learned organically that smooth, fluid motion in a simulation actually requires the tiny, fractional steps that only decimals can provide. The Pygame loop, RGB tuples, and random generation methods. Without pulling out a single flashcard, your simple active play just taught you the foundational anatomy of a Python project. It completely proves that twisting knobs, experimenting, and seeing immediate visual feedback is absolutely the fastest and most effective way to learn syntax. Which leaves us with this final thought. You've just seen firsthand how a few simple tweaks can completely change a calm sky into a chaotic warp drive. So now that you know how to manipulate an entire universe within a single script, and you truly understand how to effortlessly learn through play, what are you going to build next?